The 1947 National Electrical Code, or NEC, is a significant document in the history of electrical safety and standardization. It provides a set of regulations and guidelines for the safe installation of electrical wiring and equipment. Examining the 1947 NEC offers insights into the electrical practices and technologies prevalent at that time. Understanding its contents requires familiarity with electrical concepts such as voltage, amperage, resistance, and grounding. The NEC is updated periodically to reflect advancements in technology and address emerging safety concerns. The 1947 edition represents a specific stage in the evolution of these standards. It's important to note that electrical codes are not static. They are continually revised to incorporate new knowledge and best practices. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. These include wiring methods, overcurrent protection, grounding, and equipment installation. The 1947 NEC would have included requirements for conductors, raceways, and electrical boxes. Conductors are the wires that carry electrical current. Raceways are conduits or channels used to protect and route conductors. Electrical boxes are enclosures used to house wiring connections and devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source. This helps to prevent electrical shock and fire hazards. The 1947 NEC would have specified requirements for grounding electrodes, grounding conductors, and bonding of metallic enclosures. The code also addresses the installation of various types of electrical equipment, such as lighting fixtures, motors, and appliances. These requirements are intended to ensure that equipment is installed safely and operates correctly. The NEC includes tables and diagrams that provide detailed information on conductor ampacity, conduit fill, and other technical parameters. These tables are essential for selecting the correct size conductors and raceways for a given electrical load. The 1947 NEC would have specified requirements for the types of wiring methods permitted in different occupancies. Wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. The code also addresses the use of flexible cords and cables for connecting portable equipment. The NEC includes requirements for the installation of electrical services, which are the connection points between the utility power supply and the building's electrical system. These requirements cover the size and type of service entrance conductors, the location of the service disconnect, and the grounding of the service. The 1947 NEC would have specified requirements for the installation of transformers, which are used to step up or step down voltage levels. These requirements cover the location of transformers, the type of enclosure required, and the overcurrent protection of the transformer. The code also addresses the installation of generators, which are used to provide backup power in the event of a power outage. These requirements cover the location of generators, the type of fuel used, and the overcurrent protection of the generator. The 1947 NEC would have included requirements for the installation of electrical equipment in hazardous locations, such as areas where flammable gases or vapors are present. These requirements are intended to prevent explosions and fires. The code also addresses the installation of electrical equipment in wet locations, such as bathrooms and swimming pools. These requirements are intended to prevent electrical shock hazards. The NEC includes requirements for the inspection and testing of electrical installations. These requirements are intended to ensure that electrical installations are safe and comply with the code. The 1947 NEC would have specified requirements for the qualifications of electrical inspectors and the frequency of inspection. The code also addresses the enforcement of electrical codes. These requirements cover the authority of electrical inspectors to issue permits, conduct inspections, and enforce code violations. The NEC is a complex and comprehensive document. Understanding its contents requires a thorough knowledge of electrical theory and practice. The 1947 edition represents a significant milestone in the development of electrical safety standards. It is a valuable resource for anyone interested in the history of electrical engineering and the evolution of electrical codes. The NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who are familiar with the code and the safe practices for electrical installations. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. The 1947 edition provides a glimpse into the past and a reminder of the importance of electrical safety. Let's delve into some specific areas that the 1947 NEC would likely have addressed. Firstly, conductor types and ampacities. The 1947 NEC would have specified the types of conductors available at the time, such as rubber-insulated and varnished cambric conductors. It would have included tables listing the allowable ampacities of these conductors based on their size and insulation type. These ampacity ratings are crucial for ensuring that conductors are not overloaded, which can lead to overheating and fire hazards. Secondly, grounding and bonding. Grounding and bonding are essential for electrical safety, and the 1947 NEC would have contained detailed requirements for these practices. Grounding involves connecting the electrical system to the earth, providing a low impedance path for fault current to flow back to the source. Bonding involves connecting metallic parts of the electrical system together to ensure that they are at the same electrical potential. These practices help to prevent electrical shock and minimize the risk of fire. Thirdly, overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from excessive current flow. The 1947 NEC would have specified the types and sizes of overcurrent protection devices required for different circuits. It would have also included requirements for the location and installation of these devices. Fourthly, wiring methods. The 1947 NEC would have specified the types of wiring methods permitted for different applications. Wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. The choice of wiring method depends on factors such as the environment, the type of building construction, and the voltage of the electrical system. Fifthly, equipment installation. The 1947 NEC would have contained requirements for the installation of various types of electrical equipment, such as lighting fixtures, motors, and appliances. These requirements are intended to ensure that equipment is installed safely and operates correctly. They cover topics such as mounting methods, wiring connections, and grounding. Sixthly, hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The 1947 NEC would have included special requirements for electrical equipment installed in these locations. These requirements are intended to prevent explosions and fires. They include the use of explosion-proof equipment and intrinsically safe circuits. Seventhly, services. The service is the connection between the utility power supply and the building's electrical system. The 1947 NEC would have specified requirements for the size and type of service entrance conductors, the location of the service disconnect, and the grounding of the service. Eighthly, transformers. Transformers are used to step up or step down voltage levels. The 1947 NEC would have included requirements for the installation of transformers, including the location of transformers, the type of enclosure required, and the overcurrent protection of the transformer. Ninthly, generators. Generators are used to provide backup power in the event of a power outage. The 1947 NEC would have specified requirements for the installation of generators, including the location of generators, the type of fuel used, and the overcurrent protection of the generator. Tenthly, low voltage systems. The 1947 NEC would have addressed low voltage systems, such as those used for lighting and control circuits. These systems typically operate at 30 volts or less and require special safety precautions. The code would have specified requirements for the wiring, overcurrent protection, and grounding of these systems. The 1947 NEC, while outdated, provides a valuable historical perspective on electrical safety practices. Comparing it to more recent editions of the NEC reveals the evolution of electrical technology and the ongoing efforts to improve electrical safety. For example, the 1947 NEC likely had less emphasis on arc fault circuit interrupters, or RFCIs, which are now commonly required in residential circuits to protect against arc faults. Similarly, ground fault circuit interrupters, or GFCIs, were likely less prevalent in the 1947 NEC compared to modern codes. GFCIs are designed to protect against electrical shock by detecting ground faults and interrupting the circuit. The 1947 NEC also likely had different requirements for conductor insulation and ampacity ratings compared to modern codes. Advancements in insulation materials have allowed for higher ampacity ratings for conductors of the same size. Furthermore, the 1947 NEC may have had different requirements for grounding electrode systems. Modern codes typically require more robust grounding systems with lower impedance to ground. The 1947 NEC would have addressed the use of knob and tube wiring, a wiring method commonly used in older homes. This wiring method is now considered obsolete and may pose a safety hazard if not properly maintained. The code would have specified requirements for the installation and maintenance of knob and tube wiring. The 1947 NEC also likely had different requirements for the installation of electrical equipment in agricultural buildings. Modern codes have specific requirements for agricultural buildings to address the unique hazards present in these environments, such as dust, moisture, and corrosive atmospheres. The 1947 NEC would have addressed the use of open wiring on insulators, a wiring method commonly used in industrial and agricultural settings. This wiring method is now less common due to safety concerns and the availability of more modern wiring methods. The code would have specified requirements for the installation and support of open wiring on insulators. The 1947 NEC also likely had different requirements for the installation of electrical signs and outline lighting. Modern codes have specific requirements for these installations to ensure that they are safer and do not pose a hazard to the public. The 1947 NEC would have addressed the use of autotransformers, which are transformers with a single winding that serves as both the primary and secondary winding. Autotransformers can be used to step up or step down voltage levels, but they do not provide electrical isolation between the primary and secondary circuits. The code would have specified requirements for the use of autotransformers. The 1947 NEC also likely had different requirements for the installation of electrical equipment in mobile homes and recreational vehicles. Modern codes have specific requirements for these installations to address the unique challenges of wiring these types of structures. The 1947 NEC would have addressed the use of non-metallic sheath cable, a type of cable commonly used in residential wiring. This cable consists of two or more insulated conductors enclosed in a non-metallic sheath. The code would have specified requirements for the installation and support of non-metallic sheath cable. The 1947 NEC also likely had different requirements for the installation of electrical equipment in commercial buildings. Modern codes have specific requirements for commercial buildings to address the higher voltage and current levels and the more complex electrical systems found in these buildings. The 1947 NEC would have addressed the use of armored cable, a type of cable consisting of insulated conductors enclosed in a flexible metal sheath. Armored cable provides mechanical protection for the conductors and can be used in a variety of applications. The code would have specified requirements for the installation and support of armored cable. The 1947 NEC also likely had different requirements for the installation of electrical equipment in industrial facilities. Modern codes have specific requirements for industrial facilities to address the high voltage and current levels, the presence of hazardous materials, and the need for reliable power distribution. The 1947 NEC would have addressed the use of mineral insulated metal sheath cable, a type of cable consisting of insulated conductors enclosed in a copper or stainless steel sheath and filled with mineral insulation. This cable is highly resistant to heat, moisture, and corrosion and is often used in hazardous locations and other demanding applications. The code would have specified requirements for the installation and support of mineral insulated metal sheath cable. The 1947 NEC also likely had different requirements for the installation of electrical equipment in healthcare facilities. Modern codes have specific requirements for healthcare facilities to ensure the safety and reliability of electrical systems that support critical patient care equipment. The 1947 NEC would have addressed the use of high-voltage cables, which are cables designed to operate at voltages above 600 volts. High-voltage cables are used in power distribution systems and other high-power applications. The code would have specified requirements for the installation and termination of high-voltage cables. The 1947 NEC also likely had different requirements for the installation of electrical equipment in data centers and telecommunications facilities. Modern codes have specific requirements for these facilities to ensure the reliability and availability of power and cooling systems. The 1947 NEC would have addressed the use of fiber optic cables, which are cables that transmit data using light signals. Fiber optic cables are used in telecommunications, data networking, and other high bandwidth applications. The code would have specified requirements for the installation and termination of fiber optic cables. The 1947 NEC also likely had different requirements for the installation of electrical equipment in renewable energy systems such as solar photovoltaic and wind power systems. Modern codes have specific requirements for these systems to ensure their safety and compatibility with the electrical grid.